So one of the things that really helps um, people learn mathematics, learn how to deal basically any task, is to kind of self-identify when they're struggling with something. And I want you to look at these two problems and ask yourself, are these problems that you continue to see and you're still fuzzy about how to do them correctly? If so, um, I think it's time that you kind of self identify you don't know how to do this, and there's two things that you need to do to correct that. One of them is these involve the laws of exponents. And right now on your test or a piece of paper that you're attaching to your test, I want you to look up in your book what the laws of exponents are, and I want you to write down all of them. There's probably a good five. Now, those are just kind of building blocks for these problems, and they have kind of a lot of simple truths that we use again and again. So, for example, if I have 7 and I raise that to the third power, and then I raise that to the second, I know immediately that's the same number as 7 raised to the sixth power. I don't even think about it, I know exactly what this is. If I have 7 to the third power and I multiply that by 7 to the second power, I know that that's 7 to the fifth power. Doesn't there's no argument, there's no debate with myself. I just know that fact. Um, if I want to convince myself of that fact, I can pick some simple numbers. I could say, for example, 2 to the third times 2 to the fourth, and I could verify that that's the same thing as 2 to the seventh power. I'm sorry, it is 2 to the seventh, 4, 5, 6, 7. It is 2 to the seventh, and I could verify that by grabbing a calculator and just seeing that if I evaluate 2 to the third times 2 to the fourth, I really get 2 to the seventh. Now, at the end of the day, right, I don't keep struggling with looking at examples like this. I just remember this fact. If I have any base that's the same, right, and I'm raising one of those bases to the b power and one of them to the c power, this is always going to be a raised to the b plus c power. In other words, when I'm multiplying identical bases, I end up adding the exponent. So a to the b times a to the c is a to the b plus c. So this is one of the laws of exponents, and you need to look up the rest of them in your book and get familiar with them because these aren't going away. On this problem, when I look at it, I can see that it all involves multiplication. I have some bases that involve x. I have some bases that involve y. And I have some integers too, right? I've got the number 3 and I've got the number 2. So when I look at this, I can tell you immediately what the answer is. 3 times 2 is the number 6, and yes, I'm multiplying 3 times 2. The other thing I have is that if an x to the first power and x to the second power, I can write these are the parts in purple that I've highlighted, but I have an x to the first times an x to the second. Um, it's an implicit factor of 1. It has to be raised to the first power, right? When I look at that, I know this totally tells me this is the same thing as x to the third. I'm not thinking about it. I'm not debating with it myself. And I can look at it. It's an x times an x times an x. There are 3 factors of x there. So this is x cubed. The other thing that I have is I have a y to the first and another y to the first. That's a y to the second power. And I'm done with it. It is that simple. It's just a matter of knowing the correct laws, being able to justify them in your mind, and then use them consistently and effectively. On the next problem, when I take a look at the numerator, I see that I've got a factor of a, that's a to the first, and then I've got an a to the third, a. Well, I know within that numerator, right, I have exactly 3 factors of a. That's a to the third power. The other thing that I see is my denominator has this value of 2 that lives inside of it. And I'm just going to go ahead and write that factor of 2 that's down in my denominator and leave it there. The next thing that I have is is b to the second over b to the negative second power. Now, I destroy negative exponents by I would multiply both the top and bottom by b to the positive second power. Okay, look, that is the number 1. I can multiply by the number 1 and not change an output. So this entire thing right here is equivalent to the thing I started with. And the reason why it's equivalent to it is because I just multiplied it by the number 1. So um, it's the same thing as if I was to say something like, if I've got the number 7 and I multiply it by the number 1. Look, 7 times 1 is the same thing as 7, right? All I'm doing is multiplying by 1. And you can see, same thing here. This entire expression is the same thing as this because I am just multiplying it by a 1. Now, when I multiply it by 1, notice what happens. This numerator becomes b to the 4th power, and the denominator becomes b to the 0th power. Well, b to the 4th over b to the 0th power is b to the 4th over 1, which is simply b to the 4th power. So this is b raised to the 4th power. It is not the number 1. Several of you looked at this and decided, hey, check this out. This whole thing is just 1 to start with. No, that's not b squared over b squared. It's b squared over b to the negative second, which is equal to b to the 4th power. So I know in my answer I've got a b to the 4th power. I don't think I'm done with this. I want to look at another law of exponent, right? So consider this is an additional law of exponents. If I have 2 to the 3rd over 2 to the 2nd power, I understand that that's the same thing. If I look at numerically, that's the same as 8 over 4, which is just the number 2. Well, take a look at this. This is also the same thing as 2 to the 3 minus 2 power, right? Here's this, I want to grab the highlighter. It's this 3, and then to the minus 2 power, right? So I'm subtracting this exponent down in the denominator. And it gives me exactly 2 to the 1st power, which is 2. Now, this problem, if you look at it, what do we have? We have b to the 2nd over b to the negative 2nd. The shortcut is that's b to the 2 minus a negative 2, right? You've got to pay attention and notice that, yeah, this rule, this law of exponents, which basically I'll summarize it here. It says if you've got a to the c over a to the b power, that's the same thing as a to the c minus b. Right? You see I'm subtracting here. Well, look at this. I'm following this pattern. I've got a 2, right? And then in my denominator, I've got a negative 2. And you can see that I am subtracting between the two, right? So I end up with 2 minus negative 2, which is 2 to the 4th power still, right? So either way, I'm still getting that this is b to the 4th power. And my final answer is I've got I left that there, and probably many of you are like, Mr. Roberts, that's still wrong. Actually, that's an a to the 1st times an a to the 3rd. How many factors of a do I have there? I do not have 3. Thank you for being patient with me and waiting until the end before I point out my mistake. But I've got b to the 4th and an a to the 4th in the numerator, and I've got 2 in my denominator. So if you stop this video like that guy doesn't know what he's talking about, hey, take a look at it, right? It's always fluid, it's always dynamic. I'm always looking at what I write down and I'm thinking about it and I'm trying to catch those things. Inevitably, people make mistakes. You're going to make mistakes. The trick is to get yourself to a position where you know enough and you've practiced enough that you're able to catch your mistakes. Let's move on.